This presentation describes the GSTP project achieved by ScanWorld and Spacebel for the European Space Agency. The project is a de-risking activity for implementing a cloud-based geospatial data store that allows serverless access to hyperspectral data. Our cloud data store aims to address two objectives. The first goal is to answer to the usual challenges of big data store, support data larger than memory, avoid I/O bottleneck, provide responsiveness, and reduce the costs. Those challenges are addressed by what we call cloud-native formats. The structure in chunks enables efficient parallel processing of memory-sustainable units. The object storage is affordable and scalable. Moreover, no server are needed to access the data. The second objective is to extend the usual latitude-longitude of rasters to other dimensions such as time, elevation or wavelength. Multidimensional data, also known as data cube, allows useful functions such condensing, subsetting and also optimization for specific queries. Looking at the wavelength dimension, accessing the light spectrum as a continuous property enables to compute new kind indexes and retrieve easily averages and other functions. During the first phase, we released an analysis report and GeoZarr emerged as the only solution to suit both objectives. We have completed benchmarking and compared to the COG format. GeoZarr appeared to address more use cases and sometimes much more efficiently. Let's have a short quick look at GeoZarr format. The spec defines the concept of array which represents multidimensional. The data is divided in chunks which fit in memory. Chunks are independent so processing can be split for each chunk. Then you can also set a pipeline of filters to compress or optimize data storage. Compress or optimize data storage. The second key aspect of GeoZarr is the storage dictionary interface which allows to map it directly the affordable cloud object storage, and make the queries very scalable thanks to the cloud HTTP servers. GeoZarr specification only miss some means to express the geospatial aspects of the data. We provided a set of recommendations which consists essentially in adopting climate and forecast conventions which provide spatio-temporal semantics. We also propose constraints to facilitate the support by third parties. And finally we adopted to space domain the existing multiscaling draft extension. This clip provides an overview of GeoZarr visualization using multiscale property, as demonstrated by Trevor Manns. The GeoZarr extension for space data was released recently and describe all recommendations collected during the project. We converted data from multiple missions and provisioned a data store to demonstrate the potential of a serverless access to data. The principle is very simple. All the business logic that is usually implemented on facade servers is shifted to the client. And a plenty of libraries are available for scientists to perform queries very easily. As with WCS servers, you can request spatial subset of the data. You can also subset the data on the temporal dimension. We also demonstrated the plotting of the light spectrum with Prisma data products. We also highlighted the asset of GeoZarr optimization, and showed that retrieving time series or light spectrum of a region can be 1000 times faster than with usual formats such as COG. Finally, we also developed a draft extension for OpenLayers to demonstrate the visualization of GeoZarr data. The company ScanWorld has also developed a set of more advanced applications relying on the cloud data store. These applications will be demonstrated in another video. Thank you for watching.